For this video, we will be going over scientific notation and some things that you should recall from your previous experience with it, but if not, it will serve as a refresher and hopefully get you on board. Scientific notation is one of the easier topics to do because it involves little math. It's more counting and moving a decimal. So once you know the direction and the amount of places, it actually becomes very easy to do. All right, so the graphic organizer that you're looking at has two parts to it. The top part is going to be about when the exponent is positive, and the bottom part is going to be if it's a negative exponent, because the two numbers are two different types. And then we'll flip it over to the back side, and I'll give you some more information and examples to work with. All right, so starting at the top, numbers can be written in standard form and in scientific notation. All right, so standard form is the typical numbers that we would normally see. Scientific notation always has to have certain pieces to it. All right, so we're going to go to this picture statement with the boxes right in the middle. Numbers that are written in scientific notation are made up of three parts. The coefficient, which is this first piece, that's known as the coefficient. The base, right, which is the 10, and the exponent, which is always going to be the little number in the air. Now there's some information you have to know about each one, right? So this first number, right, is also known as the first factor. Right. And the rules that go along with this first factor is that it is going to be a number including a decimal, so you'll always see a decimal, but it must have a number 1 through 9 in front of the decimal to be correct. So when you're looking at scientific notation and you're trying to decide if you've gone far enough or if it's written correctly, there can only be one digit in front of that decimal, and it cannot be a 0. It has to be the digits 1 through 9. If there's more than that or less than that, then you have to move the decimal to make it right. All right, but correct scientific notation only has a single digit in front of the decimal. All the other numbers go behind the decimal. For the base part, it is always a power of 10. That'll never change. And you do have to write the 10. Right? Then for the exponents, there's two types of exponents. There's the positive one and the negative one. They tell you different things. So when you have a positive exponent, it's going to tell you which way to move the decimal. So positive means move decimal to the right that many times. Okay, so positive exponents mean you're going to go to the right, right? Just like positive numbers on a number line, go to the right. You can use that as a way to remember it. The other part that the exponent is going to tell you is if it's a positive exponent, it means that your number is getting bigger. So in order to make numbers get bigger, then you're naturally going to move the decimal to the right to make them bigger. Otherwise, they get smaller, right? So both of those things are happening at the same time when you actually move this decimal, right? So the way we do this is we take the 5.2, and we take the decimal and we're going to move it according to this problem 7 times. And it's to the right. So we go 1, 2, 3, 4, 5, 6, 7, and you fill in all those empty spots with zeros. Right? And then you have to put commas in from the back every third number. So there'd be a comma here and a comma here. And then you write your final number in standard form. So this would be 52 million by the time it's done. So 5.2 times 10 to the 7th power is the same thing as 52 million in standard form. All right, so now if you'll come to the bottom chart, or bottom part of the organizer, we're going to do the same thing, but this time the big difference is that the exponent is negative. So a lot of our things are still going to be the same in terms of pieces of scientific notation. The first number is a number including the decimal, all right, and again, it can only be a single digit. Of 1 through 9 in front of decimal. That will always be true, no matter what kind of exponent you have. Okay, and then the same thing that'll always be true with the base is that it's always a power of 10. The thing that's different though is because your exponent is negative, right, the exponent part tells you a little bit more in this case. A negative number, if you think of negative numbers on the number line, those are to the left of 0. So if there's a negative exponent, you're going to move left that many places. Okay. And because we're going left, our numbers are not getting bigger, right? This means that your number is getting smaller. And when numbers get smaller, the zeros go in front of the other digits. When numbers get bigger, the zeros go in the back. So that's how you can tell if you're going to end up with a negative exponent or a positive exponent. If the zero's in the front, you're going to have a negative exponent. If the zeros are in the back, you're going to have a positive exponent. All right, so once you learn these little tricks about it, it's pretty easy in terms of figuring out what you want to write. All right, so if we're going to take this decimal of 3.2 and we want to move it -5, all right, that's our exponent, so that means we're going 5 places to the left. So I'm going 1, 2, 3, 4, 5. There's its new home. Fill in all those spaces in front of the 3, 2 with a 0. So our standard form would be decimal point 0, 0, 0, 0, 3, 2. Notice that is a very small number, right? And that's what the negative exponent did, was make it a smaller number to start with. All right, so if you go to the back side of this sheet, right, we've got a couple more definitions and information pieces and some practice problems that you can use to help you as you go through and try to do your Edmodo quiz. All right, for scientific notation, the definition, or basically what it's used for, scientific notation is used to express really small or large numbers. It saves us from having to write those really tiny numbers or really large numbers in standard form because they take up so much space. Scientific notation takes up less space. Every number can be written in scientific notation, right? But the really big ones and the really small ones are the ones it's most useful for, right? And in terms of the parts to the number, this is a recap of what was on the front. If I give you 2.07 times 10 to the 8th factor, or to the 8th power, this 2.07, that's known as your first factor. Remember, we had rules around that. And then the 10 to the 8th power is known as your second factor. Okay, so those are the official names that go with it. All right, so we're going to practice converting back and forth. The first thing that we want to practice doing is writing in standard form, which is what I had you doing on the front as well. Right? Most students are more successful with this part than they are the next part. Right? So again, I've reminded you up there that a positive exponent means that it was a bigger number and that you're going to move to the right. And if it's a negative exponent, you want to make it smaller, so you're going to go to the left. So for number 1, my exponent is a +4. That means I'm going to take the decimal and I'm going to go 4 times to the right. 1, 2, 3, 4. Fill in your zeros and then put your commas in there. So the final number is 53,400. Right? For number 2, it's a negative exponent, so I'm going left. So 3.27, go 1, 2, 3. There's its new home. Fill in the zeros in front. So my new answer is 0.00327. Okay. For number 3, my exponent is a 0, which means I don't move it at all. So my answer is just 3.714. If there's nothing to move, you don't have anything to do to it. So be careful about that. Then with the power of 6, that's positive, so I'm going to go right. So for 7.42, 1, 2, 3, 4, 5, 6, fill them in. And then from the back, put your commas, so it'll be 7,420,000. Right? And that's going from scientific to standard. So now let's take a look at the reverse. Okay? The biggest thing you need to remember is that if it's a number bigger than 10, it's going to have a positive exponent. If it's a number smaller than 1, in other words, if the zeros are in front of the decimal, you're going to have a negative exponent. So look for where the zeros are. Zeros in the back is positive, zeros in the front makes negative. Right? It doesn't make the number negative, it makes the exponent negative. All right, but the biggest trick is trying to figure out where is your decimal currently if you don't see one. If you don't see one, the decimal is always in the very back. And you've got to keep moving that decimal until you only have one number in front of it that's not a 0. So if I move here, that's not enough. Here, not enough. Not enough. Not enough. Not enough. I've got 32.75. You can't have that. So I need to move it one more time. So I have 3.275. You don't include the zeros unless they're stuck in between other numbers. Okay, and that's the first factor. Then you're going to say times 10, and this is the only time you get to use an X. If you want to use a dot instead, that's fine, all right, but this is where I will allow you to use an X. And then we've got to count how many times did we move it. 1, 2, 3, 4, 5. We moved it 6 times, and because the zeros were in the back and it started as a bigger number, it's a +6. Okay, don't get confused at the fact that you were moving left. Don't think about that. Think about where the zeros are. All right, so for number 2, I can see the decimal. It's right here in the front. Notice your zeros are in the front, so that means you're going to have 10 to a negative power when you get down to that piece. All right, so now we need to figure out the first factor. We keep moving this decimal until something other than a zero is in front of it. So if I'm right there, there's no other number other than zeros. I need to move it one more time. So it's 3.16, and then we moved it 1, 2, 3, 4 times. And because the zeros were in front, that means it's a -4 for an exponent. Okay. You can always take your answer and convert back and see if it matches the problem you started with. For number 3, the decimal, remember, is in the very back, so I need to scoot it until I get only one digit in front. So not enough, not enough, not enough, there's enough. So 1.414, you don't need that other zero, times 10. Because my zeros were in the back, that means it's a positive exponent because it was a bigger number. And I moved it 1, 2, 3, 4 times, so that's +4. Then if you look at number 4, the zero's in the front, so that means it's going to be a negative exponent. And when I go to move it, I only have to move it one time to get a number in front of the decimal that's not a zero. So that's 1.18 times 10, and you do have to write -1. Okay, ones have to be there in terms of exponents. Okay, every number that is an exponent has to be written. There is no invisible exponents. Okay, so we're going to be practicing with this, and we're going to be embedding these into our comparing and ordering situations. So now that you know how to convert back and forth, this should make things a little easier for you.